All right, folks. Calculus. Welcome to your notes for Friday, October 15th. We are starting section 2.6. Day 1 will do about 2.5 days with this. Limits involving infinity are actually pretty easy because we can use the rules about horizontal asymptotes that we learned in college algebra. So limits involving infinity. It's all about the horizontal asymptote, not the alternative hypothesis, the alternate hypothesis from stats. Some of you might know that one. All right, folks. As you know, we are brought to you by Crystal Light Pure Energy, Noon Electrolyte Energy, Cliff Bar, seasonal flavors, and Laura Bar. Today, coffee cup sponsor, Illinois, not the Chicago part, God's countries, Central and South. We have an in-studio classroom there. A little switch the order today. It is a Friday that you should be watching this, and Friday I'll be using the sweets. What's Knee Rover? Yes, I believe that is Stuart the Minion there is keeping it cozy for me until then. All right, my trusty teaching assistant, Stuart. All right, folks, let's get at these notes. Section 2.6. So this is when you're supposed to be watching this. Friday at, what time do you guys come in? 9:40 class starts. I will probably still be off in sleepland at that time. All right, so anyway, do this well. I will definitely not be watching you on Hapara on this time, but Mr. Casabom should be with you there, Coach K, so ask him if you have any questions about these first parts of our notes for section 2.6. So here are a few examples of the long way. Then I'm going to show you how you can answer these questions in your second homework set. Evaluate each limit. So we have the limit as x goes to infinity of x plus 4 over x squared minus 3x plus 8. So we learned a few weeks ago that 0 over 0 is indeterminate. Well, infinity over infinity is also indeterminate. And you can make the same plus, why am I writing like that? Plus or minus infinity over plus or minus infinity. All right. Is indeterminate. All right, this doesn't tell you anything. You can't say, oh, infinity over infinity, that's somehow 1. So my answer is 1. That is not the case. So what we're going to do is you always divide. Here's the long way. You're going to divide everything in the numerator and denominator by the highest exponent in the denominator. All right, what is the highest exponent in the denominator? X squared. So every single term is being divided by x squared. Divide that, and that by x squared. Right? The limit as x goes to infinity of all that, sorry. All right. So the limit as x goes to infinity of 1 over x squared plus 4 over x squared over 1 minus 3 over x plus 8 over x squared. Now think about this, folks. Get out that calculator. I know that 1 divided by infinity is technically not 0, but my goodness, this is going to be close to 0. Let's do a little experiment here. Let's do 1 divided by, all right, 1 divided by 2 and just 2, 5, and I'm going to put as many zeros as possible. Holy cow. I mean, yeah, your scientific calculator says E 4 times 10 to the negative 30th. All right, well, let's keep going here. That clearly wasn't enough. Let's see when it's like, all right, enough's enough. It's just 0. That's pretty impressive. 10 to the negative 52. All right, anyway, you keep doing this and get as close to infinity. Calculator's going to say, look, man, it's 0. All right, so 1 over infinity is 0. 4 over infinity is 0. Heck, even 100 over infinity is 0. Now, this is 1 because I had x squared over x squared. 1 minus 0 plus 0, because again, 3 over infinity, negative 3 over infinity is 0, 8 over infinity is 0. So I'm left with 0 over 1, which is 0. Now, notice where the highest power was. The highest power of x was in the denominator. And in college algebra, this is one of the things we wrote. So going back to college algebra and the horizontal asymptote rules, I would write this down. If the highest power is in the denominator, which it is, then the horizontal asymptote is y equals 0. So the limit as x goes to infinity is y equals 0. You guys were actually finding the limits, a year and a half ago, believe it or not. So that's why we get 0. Now, I'll show you how you can show me that in an answer later on. But for these first 3 or so, we are going to show the long version of the work. And, if you say Calc 1 again, be prepared to show this work. Sometimes I allow you some shortcuts because, I think you just point and be like, well, this is what it means. Hence, this is the answer I'm going to get. And sometimes the doctorates, the doctors of math there don't like that. So be prepared to show the work this way. Limit as x goes to infinity of this rational function. We're going to divide everything by x to the third. All right, why? Because that's the highest power in the denominator. Also, is the highest power in the numerator. Hint, hint, wink, wink. So divide everything, all the terms, by x to the third. Do that as well. Take your time on this. We're going to take a little coffee break. Coffee today is brought to you by Dubuque Coffee Company, a fine St. Louis coffee roaster. All right. Unfortunately, we do not have a Saluki plush toy like we have the 2 Billikens, and as you know, the dogs are 5-1. Can I get another go, Salukis? Go dogs. All right, the limit as x goes to infinity of that when I divide everything by x to the third. When I divide everything by x to the third, I get that rational function, which means if I let x go to infinity now, it's essentially going to be 3 over 5. 3 over 5. Notice how the highest power, x to the third, was located both in the numerator and denominator. So if the highest power in the numerator is equal to, I'm just forgetting a bunch of those, to the highest power in the denominator, then the horizontal asymptote is the ratio of the leading coefficients. The leading coefficient, that is the coefficient attached to the highest power. We did those type of examples. I asked you what the power of function was and what was the LC, the leading coefficient, in college algebra as well. So, you could have like a x to the third written over here. 3 is still the leading coefficient because it's attached to the highest power. So, I could look at that and be like, oh, the limit is 3/5. All right. Again, I will show you how you can do that the shorter way very soon. Example 3, we have the limit as x goes to negative infinity of that function. Now, I have the notes mentioned to me that we're going to look at Desmos, and I do not have the computer right next to me, so I'm going to run and get that. Well, folks, as there is lovely radio silence here, divide again. What is the highest power in the denominator? It is x. Divide everything by x. Well, I go get that Chrome. And we're back, folks. All right. So looking at Desmos, and Desmos is so great. If you ever want to see what a graph looks like, that's exactly what we want to do right here. Okay, so first off, let x go to negative infinity. If you let x go to negative infinity, that's going to be 0, that's going to be 2, that's going to be 3, that's going to be 0. This is going to get infinite. Does it get infinite, though? When you have a negative 4 times a negative infinity, you're thinking like, oh man, is that going to be positive infinity? What's that going to be? So I'm going to tell you that in this case, that doesn't matter as much whether it goes to negative infinity and positive infinity, how we're going to give our answer. So the graph here is quite helpful. All right, so again, you can have Desmos out. Which one are we looking at? We are looking at the one in red, right? Yeah, so the one in red is, I graphed it, and what do you know? It's in red. So as x goes to negative infinity, it's going to the left, so look at it to the left. Let's look at this bigger and bigger. I can just keep stretching it. Actually, I don't want that. I'm gonna zoom. Ah, okay, great. Great. We need to do that. Excellent. I actually did not look at that yesterday. So this is good. This will help you out. What you have here is an asymptote, right? You've got a vertical asymptote at x equals a negative 11 over 3. And this is good. We see both of those right there, both those functions. We're going to take a look at the green one. So as x goes to negative infinity, it's technically, it's not going south, because this is as x goes to negative 11 thirds, because there is an asymptote there, a vertical asymptote. But as x is allowed to go to negative infinity, all right, this is great. This will cause you less confusion. Where is y going? It's going to infinity, right? So, and it's not going beyond infinity. Notice how Buzz is not in the studio audience here. All right, he's not allowed in math classes anymore. So, look at Desmos here. I'm going to let you say that, you know, the limit, you get your good, I should have brought the Mean Girls coffee cup that my wife, believe it or not, has. As x goes to negative infinity, we clearly saw from Desmos that the graph just keeps going up and up. It's going to infinity. And yes, a negative 4 times a negative infinity is essentially going to give you infinity, all right? But you can also say, instead of worrying about, oh, is it negative infinity and positive infinity, it's not bounded. Like, it's going to keep approaching infinity. There is no limit, all right? So technically, you can say that the limit does not exist. That is going to be fine, because your instructions are going to say, find the limit if it exists. The limit doesn't exist. All right, it's not bounded. It's not clearly going to some number. Okay, so but we saw that it was going towards positive infinity. Desmos was very happy or helpful there. And again, what was I going to have? If x goes to negative infinity, that was going to be 0. That was going to be 0. You're going to have 2 plus, because negative infinity times a negative 4 is infinity, all over 3. Well, infinity over 3, you can divide infinity by 1,000. It's still going to be infinity. But you can say the limit does not exist, okay? Notice how the highest power was in the numerator. Let's do one more of those. Example 4, highest power is in the numerator again. So the limit is x goes to infinity of x squared plus x over 3 minus x. Divide all by x. Divide all by x. All right, so again, if you let x go to infinity, now I'm looking at positive infinity and negative infinity. If you let x go to infinity, you're going to have infinity over, ooh, look at this. So what's going to happen? So I, again, am using the graph here. What we have? We had x squared plus x over 3 minus x. And I want to show you graphically. As x goes to infinity, first off, Desmos is great, because the limit you can always evaluate using a graph as well. So the one in green here, in fact, I'm going to get rid of the one in red now. The one in green, and let's, nope. You can tell I don't. What am I doing? I clearly don't use Desmos a lot. I have made a mistake. We need to try this again. Can I reload? All right, this is going great. I'm honestly surprised I only have 250 subscribers. X squared plus x over 3 minus x. Well, here's how I use Desmos. You can write x and go down here to where it says keyboard and hit squared. X squared what again? Plus x. All right, it's plus x. And then I can do a little backslash. Oh, be careful here. I can put this in parentheses, and I can use the backslash here by the question mark down below. And I believe we had 3 minus x, did we not? 3 minus x. Okay, so that's my function. And if you don't like seeing the parentheses there after you've utilized them to show that you're dividing the entire x squared by x by 3 minus x. There we go. All right, so as x goes to infinity, right, so you have an asymptote at x equals 3. See, like in the one in green, I didn't zoom out enough to see. You got another part here, right? So you got 2 different curves. So as x goes to 3, you know, you have a vertical asymptote at x equals 3, and it's going up there. So this is not going to continue to x is infinity. All right, it's going to continue to be to go to where x is 3, and then it's going to jump down, and everything 4 or more gives you a negative y value. So actually, as x goes to to infinity, as x goes to a positive infinity, your y value is going south, south, south. All right, and as x goes to negative infinity, oh, I did not mean that. As x goes to negative infinity, what's happening? Your y value is going north, north, north. It's going up forever. All right, so we saw as x goes to positive infinity. And let's adjust this camera. This is honestly, have I made a better video than this class? All right, as x goes to positive infinity, again, algebraically, you can do this as well. You got infinity over 1, which is negative infinity. We saw that by a graph. Again, limit does not exist. And as x goes to negative infinity, I got the same thing here, 0, 0. But then I have negative infinity over negative 1, which is infinity. Again, I saw that graphically. Okay, both of these, you can just say that the limit does not exist. Okay, use this as example for A. The limit as x goes to infinity, and the limit as x goes to negative infinity. Okay, if it goes to infinity or negative infinity, the y value, you can just say the limit does not exist. When the highest power is in the numerator, there is no horizontal asymptote. We said that in college algebra. There's no horizontal asymptote. So we can say that the limit does not exist. Now, if they differ by 1, you guys might have written down something called oblique asymptotes, which help you shape the graph, but still your y value is going either to infinity or negative infinity. So for our purposes, the limit does not exist. Okay, so those are the 3 rules. I do believe I have a few special examples here, and then we get to day 2. Okay, some special ones. I'm a big fan of these. All right. Oh, man. What could we do here? Okay, so the highest power in the denominator is x to the 3rd. So I'm going to divide everything by x to the 3rd. Divide by x to the 3rd, divide by x to the 3rd. But remember, you're going inside of a square root here. So I wouldn't put x to the 3rd in the square root, because when you take the square root of x to the 3rd, you get x to the 3 over 2. So actually, inside the square root, I need to put x to the 6, because the square root of x to the 6th is x to the 3rd. So inside the square, and then you guys are going to see, there's another way that we can do this. I'm going to show you the simplified way to do this. But technically, x to the 6th would need to go into the square root. And I made a boo-boo before. 1 over x to the 6th, and this would just be 4 inside the square root. This is 2 over x to the 3rd, and this would just be minus 1. Now this is essentially, because if you're going to let x go to infinity, well then this is just going to be 0. And this is essentially going to be 0. So notice I use the approximately. This is essentially The limit as x goes to infinity of the square root of 4, 0 plus 4, over 0 minus 1, a negative 1. Well, the square root of 4 is 2. 2 divided by negative 1 is a negative 2. Now, here's the way I will allow you to do this question, okay? So if you got the root involved, or we'll see a few other ones. So the limit as x goes to infinity. This 1 is not going to play a role at all. If x goes to infinity, this 1, it does not matter. It's not going to be too useful. Not going to have an impact. Nor will this 2 have an impact. If this is going to, so this will be going to negative infinity. So this is essentially the limit as x goes to infinity of 4, the square root of 4x to the 6th divided by a negative x to the 3rd. Well, the square root of 4x to the 6th is 2x to the 3rd over a negative x to the 3rd. Look at that. The powers cancel. You get a negative 2. So I will allow you to do that question like that. And this is our final one, example 6 for the day. The limit as x goes to infinity of the square root of 2x squared plus 1 over 3x minus 5. This is essentially the limit as x goes to infinity. Do use that. All right, do use the approximately. Because it's not exactly equal to approximately. For our purposes, it will always still lead to the right, the correct answer. All right, it's going to be the square root of 2x squared over 3x. That positive 1, that negative 5 won't have an effect if x is going to infinity. All right, so square root of x squared means x is going to come on the outside, root 2 over 3x. Notice now the x's cancel, and you have root 2 over 3. And that is the end of day 1, folks. I didn't do any of the simplified versions on the other ones, like if the highest power is in the numerator, denominator, or equal, and I will show you those on Monday's notes. But if you have any with the roots like this on your homework, you can definitely do them as such. Definitely over the weekend, try to clean up any of the other homework questions. A few of them with infinity you might want to look at, but there's a lot of that first homework set that you can do. All right, this is Yak Math Videos signing out.